Hello, we are going to be talking about lines and planes in space, and I have some true-false questions that seem to always trip people up. So the first thing is to read the directions. True or false, assume that the figures are in space unless otherwise stated. That is super important for a lot of these questions. So we'll talk about that as we go along with each one. So number one, two lines must either intersect or be parallel. That is false, because if you remember, there's also such a thing as skew lines. Skew lines are neither parallel nor do they intersect. So that would be the counterexample to that problem. Number two, in a plane, so that's the otherwise stated part, in a plane, two lines perpendicular to the same line are parallel. That is true because they said that it's in a plane. So imagine if you drew a plane figure and then you had two lines that are perpendicular to the same line. So here's one line perpendicular and another line perpendicular. Well, those two lines have to be parallel to each other, so that is true. Now number three is almost identical, but it says in space, two lines perpendicular to the same line are parallel. We do have to say false to that, and I'll show you why. Okay, let's say we have the same line hanging out here in space. And now I need two lines perpendicular to that. So let's say I draw one like this, going directly to the left with a 90-degree angle. Now what if I draw one like going in the background here? And that's a 90-degree angle. This line and this one are actually skew with each other. They're not parallel. So that is why number three would have to be false. Number four, if a line is perpendicular to a plane, it is perpendicular to every line in the plane. This answer is going to be false. It's because they needed to say, let me move that word actually, put it here. They needed to say it is perpendicular to every line in the plane, and then they would have to say that passes through its foot. Okay, and let's just take a look at that. So if I have a plane figure, and then I have a line coming down that's perpendicular to the plane. What if I have another line in the plane over there? They're not even touching, so I can't say that they're perpendicular to each other. But if they had said that passes through its foot, then they would be talking about every line that passes right through that point. And then that would be a true statement, but they didn't say that, so we have to say false. Number five, it is possible for two planes to intersect at a point. That is just false. When you have two planes, they intersect at a line. Like imagine in a box shape. We have two planes right there. They're intersecting right along that line. And that's what always happens. It's impossible for them to intersect at a point. Number six, if a line is perpendicular to a line in the plane, it is perpendicular to the plane. Well, let's draw this. Okay, so I will have my plane. And what if this plane is tilted so that I have, let's say I have a 90-degree angle in the background here, 90 degrees. But what if I take that line, let me actually redraw this. What if I tilt the line that, so that in the back there's still a 90-degree angle, but on the side right here it's definitely not 90. Let's just pretend that it's 70 degrees. So this would be false. There's actually a theorem that says if a line is perpendicular, and I'll add the words that we would need, to not just a line, but if you say if it is perpendicular to two distinct lines in a plane, then it is perpendicular to the plane. That would be true if they said that. So if they said that, if they said this, then it would equal true. But they didn't say that. Number 7, two lines perpendicular to the same line are parallel. Now notice they didn't say in a plane or in space. So we assume in space, like the directions told us to. So assume space. Well, if I have a common line and then I'm going to make two lines perpendicular to that, one of the lines, maybe it's coming through like this, and so that it makes a 90-degree angle like that. What if I draw another line right here with a 90-degree angle? I think you can see that this line coming like that and this line right here that would keep going are not parallel. So this is another false. And it's because it was in space. Number 8, a triangle is a plane figure. That is true, because think about a triangle. One of the basic ways to understand that it's true is that you have 3 non-collinear points when you draw a triangle. And you can think of those as the vertices of the triangle. So that's why this would be true, because 3 non-collinear points determine a plane. And a triangle is a flat surface as well, because you cannot have a curved surface if you're calling something a plane. So that is the other important thing, not just the 3 non-collinear points portion of it. Now number 9, a line that is perpendicular to a horizontal line is vertical. Well, you know what, on a flat piece of paper, that's true. Horizontal, vertical, perpendicular. But remember, we're assuming in space. So if I have a horizontal line in space, what if I draw a line perpendicular to that that's coming kind of like from the background? And then in the foreground, and then we say that that's 90. Well, this is horizontal, but the second one that I drew is not vertical. So because they're talking about in space, this would be false. And then we have 2 more questions. Number 10, 3 parallel lines must be coplanar. Well, 3 parallel lines certainly could be coplanar. They could be just all right in a row and laying flat on the same plane. But they don't have to be coplanar. Like I could draw one back here in the background, like this, and then draw another one further up, like that. It might be a little bit hard to see still. Think about a box shape. And then we have, okay, think about this. So we have 3 parallel lines here, here, and here. But those 3 are definitely not in the same plane. So to say that they must be coplanar, that's false. And then our final question, every 4-sided figure is a plane figure. Well, that is false because what they're trying to get you to imagine, what if it's a piece of paper with 4 sides and then we bend it, kind of like in an arch, like this. So imagine this is a piece of paper that I'm holding in my hands and I bend it like in a little curve. That would no longer be a plane figure. So because of that, we would have to say false. And, you know, the other thing you can do with questions like this is take a piece of paper and take a pen or pencil, have the piece of paper be your plane, have the pen or the pencil be the line, and if you need more than one, grab more than one, and then just start trying to arrange things in space the way that they're saying. Like especially with like number 9 right here. If we take 2 pencils and we put one horizontal and then we put one perpendicular to that, and we try to keep it perpendicular but make it so that it's not vertical, you'll see that that's possible for it to not have to be vertical. So then that'll point you in the proper direction of saying false to that answer. So those are just some pieces of advice that you could use for these types of questions.